Good afternoon. So today I'm going to concentrate on one particular structure where we did some repair work, but I'm going to highlight probably two other applications where we partnered with Uretek to help us solve some problems that we had, some of our bridge structures. The structure we're primarily going to be discussing is in Samerton, New Hampshire. This is on the I-93 corridor, about 20 minutes north of Concord, if you're familiar with where that is. This is a cast-in-place concrete box that was constructed in 1962. It's a single 24-foot clear span under variable cover, but 9 to 12 feet of cover. In 2008, the culvert rating was reduced to 4, which puts it in poor condition, which put it on our radar as needing to come up with some type of rehabilitation plan. So we initially started work in October of 2020. During construction, there were various contracting joints added to the box, and these pictures show some typical conditions of those. The original detail for the contraction joint showed to paint the joint with colorless oil. And I don't know what that is, what the intent was. It doesn't keep out water, right? And the plans didn't give any other type of waterproofing on the roof of the structure. So as you can see, water has been migrating through for a number of years. So this is a buried concrete box. It's definitely worth preserving to extend the life of the bridge. We didn't really consider any type of open cut option under I-93. We were concerned about starting to lose fill. The concrete had deteriorated to the point that we thought we were going to start losing concrete, or going to start losing fill under the interstate. And what seems like a minor fix to improve the culvert rate is actually pretty complicated when we started looking at how we're going to access it and what kind of repair techniques we're going to use. So we needed to come up with a solution. And so someone that recently retired from my bureau was down at the TSP2 National Meet in Florida and met a vendor that might be able to help us with a solution.
So I guess that was us. Uretek came in. I represent Virginia, Maryland, Delaware, New Jersey. So the gentleman from New Hampshire couldn't make it, so here I am. But we're a Houston-based contractor. We have reps in every state except Hawaii, but we cover the entire country. We actually have affiliates in Canada, Mexico, Spain, and Italy. So we're expanding worldwide. We've been doing this over 30 years. We're a chemical grouting company. We fix structures, roads, pavements. If it's a good fix, it's typically less time consuming and a lot less money involved in the project if we can extend the life of the structure. And that's really our goal, is to extend the life of the structure. So like I said, we lift pavements, we fix bridge approaches, bridge departures, slabs, subsurface compaction. I was just talking to Tim, we do a lot of sinkholes in northeast Pennsylvania, not far from here in Bethlehem. Done many projects up in that area with PennDOT and New Jersey DOT and NHDOT. We have some projects hopefully slated for this October. I think some of the guys might be here from NHDOT that we're trying to get these bridges taken care of. And we seal underground structures. So culverts, things that leak and just need sealed up and structurally sound. This product's a good fit for that. We have a tremendous amount of testing. I think one of the most important things to understand is environmentally friendly. So it passes the NSF 61 certification. It passes the New York Panel DOT test for water absorption, because you wouldn't want to use a polymer that absorbs water and could cause problems in the future.
So based on the information we learned about Uretek, we spoke with our friends over in Bridge Design, and we initiated a capital project that was referred to as Samerton 16154. And they drafted a special provision to cover the use of the material and came up with repair details that involved drilling through the top of the concrete box, installing the polymer, stabilizing, densifying, sealing the soil above the joint, then removing the deteriorated concrete. And the plan was to core down through I-93 and then place concrete, fresh concrete into that repair area. The project was advertised in the fall of 2017. You can see there the engineer's estimate was right around $500,000. The single bid that was received was for $770,000, so substantially more. And when we look at the engineer's estimate versus the bid, there was a large increase in mobilization, there's a large increase in the cofferdam item as well as the concrete. And not having spoken with the contractor to place a bid, I think part of what they were building in there was a little bit of risk on their part, right? It's not a material that we've used or a technique we've used in New Hampshire before. And so if you're fearful that things may go wrong, then you try to build a little bit of risk into your bid. So then the low bid was awarded to Bridge Maintenance, and I put awarded in quotes because sometimes we don't ask to be awarded these bids. We kind of, if it's not, they're not going to do it, then it becomes us that has to do it. So as an aside, the work we did on in Samerton, both northbound and southbound, as well as all the Uretek invoices from the various projects, our total cost was around $220,000. So we were indeed the low bid. Congratulations. What was interesting was I attended this conference in Burlington in 2019, and there was a presentation by NHDOT, and they were talking about sealing abutments, which actually was reviewed a little bit yesterday during their presentation. And one of the subcontractor they used was Uretek. But the reason I'm bringing it up was during the presentation, they were talking about how they salvaged used aluminum signs out of dumpsters to help seal up the cofferdam. And that sounded pretty gangster to me. And I was new to the group. I don't know a lot of people, but I just realized, like, this is where I belong. Like, these are my people. Because that is something we totally do in New Hampshire. So we started to prepare for them to come in. I mentioned the access was difficult. We only had access from one side. The landowner on the inlet side wasn't interested in talking to us about access. There's fairly deep water there all the time. The water level doesn't fluctuate often. So the crew set up Dayton brackets and actually a staging raft to be able to access the contraction joints to be able to do the concrete removal work once the soil was stabilized. In October of 2020, Uretek was able to come in for the first time, and we started, their crew started to install the 3x3 grid each side of the contraction joints, and then do the injection. We knew it was working because we had a lot of water coming out of those joints, right? As they were doing the injection, working along, we'd see water coming out. As they densified the soil and started to produce free water, it would come out through the joints. And we started to get some lily pads that would float down, that come down, expand in the water. We did have, we were told this might happen, so we had a silt boom up to capture them so we can bring them up and not let them float downstream. After the work was done, we noticed there was definitely an improvement, but that some of the joints were still leaking. And so we spoke to our sales rep, and we kind of came up with a different plan. We were going to send a different crew up. And we were going to have to come up to work on another couple of different sites. And so they said, well, we're going to come up to the different sites. We're going to redo the work in Samerton from inside the box. We're going to consider it warranty work. And where we were normally paying them a mobilization fee and a cost per pound of material, there was not going to be any fee for the work to that quote-unquote warranty work in Samerton, which, you know, I work for the state, I'm cheap. That sounded pretty good to us. One of the other applications we had them work on was a bridge that became undermined during a flood event. This is in Lumster on New Hampshire 10. It's an old concrete slab constructed in 1948, short span, it's only an 18-foot clear span, essentially no cover. But you can see in the lower left, we had the river come up and it washed out behind the wing and the abutment. So we had a couple crews move in and we ended up installing cofferdam and we installed some formwork, and so we placed a bunch of concrete underneath that footer, and then we backfilled with compacted structural fill behind the abutment and the wing. And so we felt pretty good about the work that we did. We knew from an underwater inspection that was done by a dive team that there was about 8 feet of penetration under the footer. And the footer is approximately 8 feet wide at the base. So we started to look at the amount of concrete that we actually pumped into the forms, and knowing the size of the form in the front, the overpour in the front, and having some decent measurements along underneath, we weren't 100% sure that we completely filled in the void. So we knew that out by the footer was good, but out towards the end, between where the roadway backfill was in and our concrete, there might still have been a void there. And so we had Uretek coming back up, and we said, oh, well, let's have Uretek come out, and we'll drill down in and we'll install some of their polymer right in that area. It is essentially just kind of make ourselves feel good. As you can see there, they did the work in December. I don't know how happy the crew was to be working in New Hampshire in December, but they showed up, and they were able to get their drill holes down into the elevation that we wanted them to be at, and they put a lot of material in there. In fact, one of the things one of our field engineer noticed was it looked like CO2 bubbles that were escaping from beneath the abutment. So we feel we were actually filling in that area, we're densifying that soil, stabilizing it, and felt a lot better about that product when it was over. Another project they worked on while in New Hampshire was they assisted our Highway Maintenance Bureau with a concrete slab stabilization. There is a series of concrete slab roads in New Hampshire. Many of them have been removed, actually. We go in over time and then take those slabs out, but this one in particular in Franklin hadn't been removed, and during the freeze thaw every year, it produced a lot of issues on the roadway, produced a lot of noise for the neighbors, and so they were able to come in, just do some coring, install the material, and then stabilize that slab, and they really reduced the vibration and the noise there. We also had them come do similar work on a bridge in Thornton. This is also under I-93. This bridge has a culvert rating of 5, so it's in better shape. It's in what we'd call fair shape. And again, this bridge also has contraction joints, and it has an expansion joint. It has very similar detail. They use that great colorless oil that doesn't hold back water. The expansion joint had a more substantial detail that included some lead sheets and water stop, et cetera. So that was probably a little bit better, but the bottom photo shows kind of a typical condition of some of those contraction joints. And so this was one where we want to kind of get to this. We want to stop the water from coming through before it gets worse. And so their crew came up. We provided them access up underneath the structure. They were able to install their drill holes and install the material from underneath. And we were able to see that water is being driven out by the expanded material. A field engineer couldn't quantify the amount of water, but he said it was a substantial amount of water that was pouring out as they were working their way down, sealing the joint up. Hey, Todd, how's it going? It's like the computer's thinking about something up here. Oh, yeah, see, just the threat of you walking up solved the problem. Yeah, I know, right? So Uretek came back to Salmon Brook. You see the crew doing the installation of the material up through the drill holes. And the lower photo, you can see some of the material coming back out. The joints have really deteriorated. In addition to water, the field engineer told us we had a mouse come running out of the joint, running along the rebar, jumped in the water, we presume, and then swam to safety. We didn't track it, nor did we tell our friends at DES about the mouse habitat we destroyed. This work was done in June of 2022, the same time we did the Thornton work. And we noticed an immediate improvement in the joints. We did spend around $25,000 in the materials over about 6 joints. I've got an asterisk next to it because we didn't track all of the material that's used during the so-called warranty work. Our crew came in, they removed the deteriorated concrete, we were able to install new concrete in that area, and it looks pretty good. I believe they took the culvert rating, increased it to 5 after the next inspection. So we did have some lessons learned that we'll utilize the next time we have Uretek come up. And we do have some other bridges we've been kind of earmarking for a future contract with them. Obviously, you need to plan on what the access is going to be inside for overhead application. There is a maximum length that the hoses can travel from their material tanks and the pump that you have to take into account, depending on how far you have to come down slopes or inside the structure, what the access is. You do need a lot of time to make adjustments when on site to avoid mobilization costs. We ran into this thing called COVID. I don't know if you guys heard of it. From the project's inception to when we're actually able to do the work, if you're paying attention, there's several year gap in those dates. And so we ran into a scheduling thing. They work nationwide. They have a fixed number of crews, and so in order to schedule the correct crew to come up to do the work and for it to work in our schedule is a bit of a thing, but we worked it out. We learned to plan on somewhere around 1,200 pounds of material per joint at a minimum. That's what we found when we were working in Thornton, and we tried to get when we went back to Samerton in order to stabilize that soil and seal it up. We had used a 3-foot grid on either side of those contraction joints, but it very depends on your situation and coordination with Uretek. We had sent them bridge plans and all the information that we had, and they had suggested that to us, but your situation might be different. There does need to be a sufficient amount of cover over the structure to do the work. We looked at a couple locations when the folks were up looking and pre-planning, and our bridges where there was less than like 4 foot of cover, they said, we really would prefer not to work in these locations. So you do need some depth of cover in order to avoid doing any damage to the road. We did have a contraction joint in one of our side slopes, and that we weren't able to tackle with Uretek because dealing with the slope is difficult for them. It's mostly about access and safe accessibility for their crews. We did have our crews do some pre-drilling, especially in Thornton ahead. The top side of that box is 2 foot thick, and so as they were working, we had crews pre-drilling the holes for them to then come through and do the ejection, which helped save us a bunch of time. And the traffic control was supplied by us, not necessarily by Uretek.
So a couple things to take into account. When you have a structure like that, you always want to try and shoot it from the bottom. You always want to try and drill directly through the concrete and get to the positive side of that leak that Tim was talking about. That particular project, because of the depth of the water, made it difficult to do that. And so we tried a top-down approach, which was semi-successful, but not successful. So to come back, and when you do these joints, you always want to try and get access inside, whether you're doing a tunnels or underground structure. And the product is expansive. So you need overburden. If you don't have enough overburden and you have an asphalt road above, we will probably stay away from that. We're probably not the fix for you because we could cause more damage than good. But just so you know, we're fully integrated. We have a licensed engineer on staff. Rex Klensman has done presentations all over the country. He's an expert in polymers. We do design work. We're compliant in every state. Whatever you need from beginning to end, if you need us to be the GC of a project and handle subs, we will. If you need us just to be a sub, we will. Like I said, I service the area, so if you guys have any questions, concerns, or projects you need me to look at, I'm certainly here for that. That's my job. So that's pretty much it. And if you guys have any questions, we're here to help.
Yep, we have time. Any questions for Tim or Toby? Back there on the right.
Has New Hampshire developed a spec for this work? And if so, what's just the generic name for this product? Do you bid it under deep injected polymers?
So we developed a special, let's see, let's get the name right here. I believe we developed a special provision for it because it's not part of our regular spec, and we not going to use it that often. Let's see here. It was item 5271, soil stabilization, polymer injection above roof slab. And then there's a second associated item with that. Good? All right.
I would just add that we have multiple specs in multiple states, so if you'd like to see one, New York, New Jersey, Virginia, I mean, I think Delaware even has a spec as well, but there's many specs out there. If you need one, we can provide that for you, and you could tweak it to however you want. Typically, it's either stabilization or chemical grouting is what they'll call it.